computer vision group in Heidelberg, as we already mentioned. Mostly working on image segmentation methods, but also on Galaxy apparently. Integration of tools in Galaxy, improving Galaxy image analysis capabilities, improving the training materials, and so on. And yeah, what I will show you is how to perform segmentation using Galaxy. A very simple segmentation, basically by thresholding. And we'll do this interactively. And then I will show you how to create a workflow out of this interactive analysis that you will have performed. And then later, I will also show how this interactive analysis workflow can be applied to a whole sequence of images instead just of segmenting one single image. And yeah, I will be using a local Galaxy instance just to get to make sure that things get queued and run really quickly, so I don't have to wait too long before I can get the jobs done. But if you want to reproduce this using a public instance, it should work just fine. Maybe the tools are located in a different section on a public instance than they are on my local instance, but they have the same name, so it should be no problem to find them on Galaxy Europe or anywhere else. Yeah. In this example, I will loosely follow a tutorial, namely the one on introduction to image analysis using Galaxy. In this tutorial, we will use fluorescence microscopy images, which are cell nuclei stained with DAPI. And yeah, we will basically start by downloading the data from Zenodo into Galaxy. Yeah, so this is my local Galaxy instance. This is what it looks like. It looks almost the same as a public instance. And what I do first is that I grab this download link here from the tutorial, and then I go into upload, paste fetch data. Then I put it here. I name the data b2.zip just to be so that it has the same name as the file that we download. And I can also say that this is a zip file. Okay, then I click start, and then I click close. And then I see that the job is turning orange, which means that it's being run. And when it will be finished, it will turn green. Yep, that's it. And then the next step is to unzip the file that we have downloaded and to extract a single image from this archive. So for this, I will use the unzip tool. I run it with input file chosen, yeah, as a file that we just downloaded, and then I set extract a single file to a single file, and then I enter the file name from the tutorial. Then I run the tool, and now it's getting, yeah, it's queued in the history. This is why it was gray at first. Then it turns orange again when it's running, and green when it's finished. Now it has finished extraction, and I can visually inspect the image. And as you can see, yeah, it's hard to see anything in the image. And the question is why. To answer this question, let's run the show image info tool. Where is it? This is wrapped around bioformats. Exactly. And what's this? Could not complete request. This is weird. This shouldn't happen. Let me reload the page. Maybe this helps. Yeah, it seems to help. Okay. Yeah, it's still running, but the output is already there. So what we see from this output here is that the image has only 16 bits per pixel, which means we have values between 0 and 65,000 that can be represented for each image pixel. And what's going on here is that the image intensities, which correspond to the image background and the cell nuclei, do not span across the whole range of values of these 65,000 values that can be represented in the image. Instead, they are focused in some section of this large range. So what we need to do to enhance the visual quality of this image is to perform some histogram equalization here. And for this, there's a tool called perform histogram equalization. And we run this tool on the data that we have unzipped before. While it is running, by the way, I want to rename this image that I've been working with at the moment to input.tiff. Okay. So here now we have the image with histogram equalization performed, and now it is much better visible what is going on in the image. Okay, and the next step will be to perform some pre-processing. We want to perform some noise suppression, for which we will use a filter to DMH tool, which is wrapped around SciPy. And we will run this tool on the histogram equalized data. Let's rename this so it gets more clear what this is. This is input underscore normalized. Save. Okay. Now for the filtering. So it's a filter to the image tool. You run it on the original input, not the normalized one. And we leave everything else on default. Okay, here's the result. And let's rename this to input underscore smoothed. Okay, and now let's again perform the histogram equalization on the smoothed image. So we can better compare the smoothed input image to the original input image, usually. Okay, so as you can see here, this is a image with smoothing performed, with Gaussian filtering performed, and histogram equalization performed. And this here is the result without the Gaussian filtering. Yeah, so you can clearly see that this image here is much more blurry. This is a side effect of suppressing the noise using Gaussian filtering. Okay, we can rename this to input smoothed normalized. Okay. Next step is to perform the segmentation using a thresholding tool. For that, we will use the threshold image tool, which is wrapped around scikit image. We will run this on the smoothed input image. And we will use Otto thresholding as a method to determine the optimal threshold for the segmentation of the image. Okay, this is what it looks like. Here, black corresponds to the image background and white corresponds to the image foreground. This is pretty nice already, but what we want to do next is to also count the number of objects that we have in the image. And for that, it is required that we identify each individual object in the image and not just the background and the foreground. This can be done using the convert binary image to label map tool, which will convert the binary image that we see here to a label map. So a label map is basically an image where each object is assigned with a pixel value that is unique for that object. And we will, let's first rename this file here to input underscore segmented. Okay, and then we run this convert binary image to label map tool in the segmented image, and we use connected component analysis to separate the individual nuclei. Okay, this is what the result looks like. So it looks like it is entirely black. This is because this is again a 16-bit image, and the number of objects in this image is something about 500, a little bit less than 500. And yeah, well, since the objects are numbered consecutively, the largest value, the largest label that we have in the image is something about 500, and 500 for a 16-bit image is almost black. This is why we see an image that looks like it is entirely black, but it is not. To see that, we run the perform histogram equalization tool again, and then we will be able to see what is actually going on in the image. So while this is running, let me rename this here to input labeled or input segmented labeled. What does the tutorial suggest actually? Yes, segmented labeled. Okay. Yeah, here's a labeled image, the label map now with the histogram equalization performed. As you can see, the individual nuclei are assigned unique pixel values. Okay. Let's rename this to input segmented labeled normalized. Okay. So now we can run the overlay images tool to perform a segmentation overlay. So we want to overlay the segmentation results with the original image. To do that, we run the overlay image tool with segmentation contours over image as the type of overlay that we want to produce. For the intensity image, we use the normalized input image. And for the label map, we use the label map that we have just created. And I think we leave everything else on default. We just activate the switch here to include the labels in the image. You will see what this means in a second. This is what the segmentation result looks like. So we have contours around all segmented objects, and we also have the number, an individual number, a unique number for each of the segmented objects. Okay, now the question is, how many objects are there in the image? Since they are numbered consecutively, we can just look at the bottom of the image, and I think the largest number that we can see is something around 424. So we should have 424 objects in the image. But luckily there's also a tool called Count Objects in Label Map, which we can use to automatically count the number of objects in the label map. Let's see how many there are. It's actually 425. So there should be a number of 425 somewhere in the image, but I haven't seen it right now. But I'm confident that it's there. Okay, so this was interactive segmentation that I have performed, and now I want to create a workflow out of this segmentation that I have done. To do that, I can use a functionality which is included in Galaxy that is called extract workflow from the history. This opens this screen here where I need to deselect the tools and the files or items from the history that I don't want to be included in my workflow. I don't want the zip file to be included. I don't want the unzip tool to be included. I don't want the show image info tool to be included. And I don't want the count objects tool to be included. I think we can include everything else for the moment. Then we click the create workflow button, and then we click on edit. This loads the workflow that is extracted, that was automatically extracted from the history. And now I will rearrange the tools in the workflow a bit, so it is easier to see what is actually going on here. First of all, what we need to do is to add a tool, namely it's called a tool, but actually it's the input of the workflow. To do that, I click on tools, and then I click on inputs, and then I choose input data set. So images in Galaxy are called data sets, which might be a bit confusing because usually when you say data set, you mean a set of images, but yeah, this is how it is in Galaxy. So an image is actually a data set, and a collection of images is a dataset collection in Galaxy. Okay, so we have this input dataset here, and I connect the output, so yeah, the input image basically, with the filtering tool. Okay, and now let's see what else we need to change. Okay, here's the overlay image tool. We choose the output of the overlay image tool as the output of the workflow by setting this check mark here. We don't need this tool here because it leads nowhere. And we don't need this tool here either because it leads nowhere. Okay, now we just need to connect the input image with the histogram equalization tool. Okay, this is it, I think. This is how it should look like. Let's save this workflow. So this is this workflow here. Now we run it, but we run it in a fresh history. So I will create a new history. Then I switch back to my previous history, and now I copy the TIFF file that I've been working with to the new history that I just created. Okay, here we go. And now here I will run the workflow that I just created. Yeah, I will run it on this image. Okay, and now we should see the individual steps getting queued one after another. Yep, this is what happens here. So these three are still queued. One of them now starts running. Some are already finished. You can also follow the progress of the workflow run here in the in this image here. Okay, this is the result. It looks entirely the same that the result looked like when we performed the analysis interactively, of course. Okay, now we want to create another workflow that we can use to perform this segmentation workflow on a whole collection of images. To do that, I create a new workflow. And in this workflow, I will include an input dataset that corresponds to dataset collection, so a collection of images. And in addition, I will include the workflow that we had just created. This is this here. I click on insert, and here it is. And now I can connect the input, so the collection of images, with the input of the workflow that we have created. Now we see that there is a different visual representation of this connection. So this corresponds now to many branches, which indicate that the images from this collection will be basically distributed into separate runs of this workflow. Okay, and we set the result of this sub workflow as output of our wrapping workflow by clicking this checkbox here. This ensures that the result from the sub workflow will be also the result of this workflow that I'm just creating. Okay, now let's close this workflow that we had just created. We again create a new history, and we will copy the zip file from the first history, which we had downloaded, to the new history that we had just created. Okay. Here it is. Now we unzip the data from the zip file, but this time we will unzip all files from the zip file, not just a single one. So this is now a collection. We can click on it, and then we will see that they are the individual images. Okay. Now we can run the workflow by clicking on workflows, and then there's an unnamed workflow that we had just created. We run it on the unzipped data. Okay. And now again, the individual steps get queued and executed, but this time there's a progress bar, which also indicates the progress of the individual steps for the different images that are being processed. Yeah, so one of the images has already finished processing. Now 4 are ready. We can already look into them. Everything looks quite nice. Yeah, that's it.